Alright, in this video, we're going to interpret the slope and intercept of a linear model and use it to solve problems about data. So we just spent the last video finding that linear model, finding slope, finding the y-intercept. Now we're actually going to say, what do those two things mean? What does a slope mean, and what does the y-intercept mean? So in interpreting the slope, we're going to use this sentence structure. As the, and then you're going to choose one of your variables. Usually it's the x variable, increases or decreases by whatever it does. Then the other variable, or usually the y variable, increases or decreases by whatever it does. So let's practice on those scatter plots we did before. So the farm worker. Here we had the farm workers years since 1900 and the percent of something. Okay, and our slope was negative 13 over 37. So that would be for every 37 years, because our run is our x-axis. So for every 37 years, the percent went down 13. That's how we could interpret that. Here we had calories burned during exercise. Our slope was 95 over 23. So for every 23 went with the x, so that was minutes. For every 23 minutes, we burned 95 calories. So that's how you would interpret that slope. Fuel efficiency. We were talking about the weight of cars and then their miles per gallon. So it looked like for every 120 pounds the car weighed, it went down one mile per gallon in fuel efficiency. Or you could see, we got that from for every 600 pounds the car weighed, it went down in fuel efficiency 5 miles per gallon. Test scores. Our slope was 10 over 1 for the test score, the change in test score over the change in the hours spent studying. So that would mean for every 1 hour you study, you got a score that was 10 better, 10 points or 10% or whatever we're measuring it. Okay, so that's how we would interpret the slope. Interpreting the intercept, we use this general statement. When the x variable is zero, the starting value for the y variable is whatever it is. Okay, so let's go interpret the ones that we've already done. So our y-intercept was 35. So that means in the year 1900, 0 years after 1900, so in the year 1900, the percent was 35. Here, when we went into the gym, so we had 0 time exercising, somehow we had already burned 5 calories. Maybe we burned them walking in the door, right? Or earlier that day. Fuel efficiency. If your car weighed 0 pounds, now this one's interesting because notice this, we're counting here by 400, so each of these is 200. So this really isn't 0, right? This is really just, this would be 1,800, right? So this y-intercept doesn't really mean what it should mean. But the real y-intercept would be when the car is 0 pounds, what would the fuel efficiency be? And that one doesn't really make sense because a car can't be 0 pounds. But there's still going to be some mathematical start value for fuel efficiency. Okay, so this equation was actually wrong, but it doesn't really matter for our purposes. And then finally the test score, so that means when you study 0 hours, you would still expect to get, our y-intercept was 50, so you'd still expect to get 50% just from what you learned in class. Okay, so let's try some new ones in your note packet. We have this scatter plot here for number of wrinkles and your age. First we need to define variables. So we have age and number of wrinkles, define variables. Identify correlation. This would, so we can maybe write age and wrinkles here. And then we need to, maybe age versus wrinkles, identify correlation. Well, it's going up, so that means it's positive. And you could maybe argue that it was strong. You could maybe argue that it was weak. It's definitely positive, and let's just say it's weak. You could argue it's strong. As long as you have a good argument, you'll be fine. You're supposed to choose two nice points and label their coordinates. So we're going to need to draw our line. These two steps should probably be flipped. So let's draw a line. Kind of looks like this line would fit our points pretty well, don't you think? So then we need to choose 2 points within that line. So let's see, it goes through this one. That looks like it could be 54, comma 54 maybe. Or 54, maybe 56, probably. Okay, and then it looks like, well, we'll just make this one into a nice point. This is 36, comma 42. Okay, so we have x1, y1, x1, or x2, excuse me, y2. And so we need to find our slope. So that would be 56 is y2 minus 42 over 54 is our x2 minus 36. All right, well that's 8 and 6 is 14, and 36, that's 14 plus 4 is 18. So we can reduce that. That would be 7 over 9, right? And now sometimes it's good to find a decimal. Okay, so 7/9 would be 7 divided by 9 would be 0.777. So 0.77 repeating over 1. Okay, and that doesn't really make mathematical sense to put a decimal over 1. But we're going to do it for our purposes today, because we're going to write a general statement about this. And instead of talking about for every 9 years you get 7 wrinkles, now we can talk about every 1 year you get 0.7 of a wrinkle. So you don't quite get a wrinkle every year. Every 9 years you get 7 wrinkles, every 18 years you get 14 wrinkles, every 1 year you get 0.7 of a wrinkle. So that would be our general statement. And you guys can write that down. I'm not going to waste our time. But for every 1 year, you get 0.7 wrinkles. Write that down. Then we're asked to find the y-intercept. It looks like maybe 13. And then what would the general score of, or the general statement about that would be? Well, when you're 0 years old, you still have 13 wrinkles, right? So our equation would be y equals 0.7 over 1 x plus 13. Okay. Let's try another one. Here, if we define variables, it looks like we're doing hours we watch TV and test scores. So hours of TV versus test scores. Identify correlation. Well, it definitely looks negative, and I would say it's a weak. So it's a weak negative. I'm going to abbreviate. We need to draw our line. We draw a line before we choose our points. And I'm going to draw maybe right through the middle, it looks like. Okay. So then we label our 2 nice points. It looks like I got this first point here. Well, let's deal with some points that are actually on the line. So this looks like 2, comma 87 maybe. And this looks like 8, comma 62. So this would be x1, y1, x2, y2. So if we calculate our slope, we'd have 62 minus 87, and we'd have 8 minus 2. Well, 62 minus 87, that is, well, let's just do it on a calculator. 62 minus 87, that's negative 25, and 8 minus 2 is 6. So let's figure that out at that decimal, divide by 6. 4.16. Negative 4.16 repeating over 1. Remember, because it's easier to talk about the general statement if you have that decimal. Okay, so if we're talking about a general statement, that would mean for every 1 hour you spend watching TV, your test scores go down about 4.16. So 1 hour leads to a decrease in test score of 4.16. Then, if we look at our y-intercept looks like it might be 97-ish, 98, something like that, which would mean the general statement, which you guys should write these down, would be for 0 hours watching TV, you would get a test score of 97. So if you didn't watch TV, you get a better test score according to this graph. So our equation would be y equals negative 4.16 repeating over 1 times x plus 97. Okay. Let's talk about this calories burned. And we've already done this one, so we can fly through this one, and you can look back in your notes. The calories, we're talking about variables time and calories. Why don't you think about what you think is the correlation? I think it's probably positive and strong. And then we've already chosen 2 nice points and calculated their slope. So let's just go get our equation from the one we did before. It was 95 over 23x plus 5. So y equals 95 over 23x plus 5. And let's fix that slope so that we have a decimal. 95 over 23. It's 4.13. So y equals 4.13x plus 5. That would be 4.13 over 1. So that means for every 1 minute, you burn 4.13 calories. And then when you haven't exercised at all, the time is 0, you've burned 5 calories. Okay? So that is interpreting the slope and y-intercept.